Hello everyone, in this video we're going to talk about the sum of two cubes pattern. So when we're talking about the sum of two cubes, the easiest way it's going to be represented is if we just have two terms that are being cubed or raised to the third power. Sometimes we're going to have some terms that are raised to other powers, other degrees, and we can rewrite them as two terms that are being cubed. And that's what we're going to look at in a couple examples today. So we look at the top of the screen in yellow, we see our pattern. So we have a cubed plus b cubed. And we can factor this, so this is a factoring pattern. We can factor this as a plus b, and then a squared minus ab plus b squared. So let's take a look at a couple examples here. So for example number one, we have 64x cubed plus 1. So hopefully you notice that one of our terms is cubed and the other is not. So we need to rewrite this as two terms cubed. Well, 64 is a perfect cube, so we could rewrite this as 4x cubed plus 1 cubed. So if we think about 4x being cubed, we would cube 4, that gives us 64, and then when we cube x, that gives us x cubed. And then 1 is also a perfect cube, 1 cubed is 1. So now we have our a and our b, right? So a would be 4x, and b would be 1, according to our pattern that we saw at the top of the screen in yellow. So now we can go ahead and write a plus b, so that would be 4x plus 1. A squared, so times a squared, so that would be 4x squared minus 4x times 1 plus 1 squared. So now I didn't simplify as I wrote those terms down, so now I'm going to simplify. You might see it to be able to simplify pretty quickly, but I wanted to make sure I showed my work here on this example. So now we have 4x plus 1, and now we're going to simplify in here. So 4x raised to the power of 2 would be 16x squared. 4x times 1 would be minus 4x, and then 1 squared is 1. So this would be our final factored form for that sum of two cubes. So 4x plus 1 times 16x squared minus 4x plus 1. Let's take a look at the next one. We have 16x to the fifth plus 54x squared. So when we're looking at our two coefficients, 16 and 54, neither one of those numbers are perfect cubes. So what we could do is factor out a common monomial, and the coefficient of that monomial needs to give us or be a factor so that 16 and 54 become perfect cubes. So if we think about 16, we'd say, okay, if I factor out a 2, I'm going to get an 8, right? 2 times 8 is 16, and 8 is a perfect cube. Great. If I factor out a 2 from 54, 54 divided by 2 gives me 27. 27 is also a perfect cube, so that is what we need to do. We need to factor out a 2, and now let's factor out an x squared. So if we factor out an x squared, that's going to leave behind 8x cubed plus 27. And so now we've created the sum of two cubes on the inside of our parentheses. It doesn't look like it yet. We have to rewrite 27 as something cubed, and we're also going to rewrite 8x as a monomial cubed. So now we can write it like this: 2x squared, and then in parentheses, 2x cubed plus 3 cubed. So now we've identified our a and our b. So a here would be 2x, and b would be 3. And now if we have our pattern memorized, we can just follow along with it. So we have a plus b, so that would be 2x plus 3. And then a squared, so 2x squared, minus a times b, so 2x times 3, and then plus b squared, and so that would be 3 squared. Now we can simplify once again, so our first binomial is going to stay the same, so that would be 2x plus 3. And now in parentheses we have a 4x squared minus 6x plus 9. And that would be our final factored form for 16x to the fifth plus 54x squared, and that is how you can use the sum of two cubes to factor.